Hello. Today we're going to talk about 11.6 analyzing data or measures of central tendency. All right, that indicates the middle of the data set, which could be used to mean the mean or the median, and the mode is also used to describe the data. Okay, so the mean is the average. All right, that's when you add up all the data and then divide by the number of data, by how much there is, right? The median is the absolute middle, okay? So the middle of the data. All right, but you got to put your data in order first. Typically we do smallest to largest, but it doesn't really matter. You're looking for the middle. And the mode is what happens the most. Typically you have just one mode, okay? But it could also be bimodal, which means it has two modes that happens the same exact number of times, okay? That happen a lot. If the data has more than two modes, then it's not useful. We don't mention it. Okay, so it either has one mode or it's bimodal. All right, so let's do an example. So here we have the number of job offers received by each student. Let's see, what are the mean, median, and mode? Okay, so let's start with the mean. So the mean is when we add it all up and divide by how many there are. Well, first let's list the data. Okay, so the data, how this is how we can describe it. This is the number of job offers, and this is how many students got that job offer. So there are 2 students that received 0 offers. 2 students received 1 offer. 4 students received 2 offers. 5 students received 3. And then 2 offers received 4. All right, so now we want to add them all up to get the mean. So if we add up all those numbers, we get 33. There are 15 numbers, so we divide by 15 and get 2.2. How we do the median is you literally look for the middle. So I just start counting. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No middle. 1, 2, 1, 2. Oh, there we go. There's the middle. So the median is 2, and the mode is what occurs the most, and we have the most 3s. So our mean, median, and mode are as follows. Let's do another example. So on this one, we have the number of trees in each yard. So we have 1 3. We have 5 4s, 7 5s, right? So to do the mean, all we have to do is really multiply them, right? So 3 plus 20 plus 35, right? We're doing this times this times this times this. Okay, that's how we can add them all up. We have 4 6s. So really we can just do 6 times 4. 24, 7, 16. And there are how many? So we add up the number of yards that we have here. So that would be the 1 plus 5 plus 7 plus 4 plus 1 plus 2. All right, we add them up and get 105 out of 20, which is 5 1/4, 5.25. That's your mean. Your median, well, since there are 20 yards, okay, that means we have 10 yards on one side and 10 yards on the other, okay? So we don't have in a direct middle, right? It only happens with odd numbers. So what you do is, since it's 20 divided by 2, we get 10. We have to look at the 10th and 11th numbers, yards. Okay, so the 10th yard, well, there's 6 yards, and we need 4 more. So the 10th yard will be a 5 and a 5. All right, so those are, which are both 5. So that average, all right, so when you have 2, you do 5 plus 5 divided by 2. So the median is 5. Okay, so I counted the number of yards. Okay, so instead of listing out all the trees, right, all the number of times, all I did was I looked for the 10th yard. There's 1 yard, there's 5, that's 6 right there. So I needed 4 more yards, and the next 4 yards are all 5s. Okay. And the mode is the one that happens the most, and there are 7 5s. 7 yards have 5 trees. So the mode would be 5. Okay. They're not always going to be the same number, but sometimes they're close. Okay. Sometimes it happens like this. All right, now for outliers. Outliers are values that are substantially different from the rest of the data. So what is that substantially different? Okay, so usually most kids come to me and they're like, oh, well, that just looks like the outlier. Bam, that's it. You can't do that, okay? Obviously, in this problem number 3, you can probably guess which one's the outlier. However, if I give you a data list of 100 values, how can you determine if you have an outlier or not? Okay, this is the issue. You need to understand how to look at bigger data sets and determine outliers. Okay, not just based on, oh, what it looks like. All right, so I'm going to show you with a small amount of data because that's easier. I don't want to sit here and list out 100 things. Okay, so I'm going to do it with a small data set so you can see what to do. All right, the first thing you want to do is put your data in order. So that would be 56, 59, another 59, 65, 65, 73, and 98. All right, first, it helps to have like a box and whisker plot. Okay, so get your median, right? So 1, 2, 3, 1, 2, 3. 65 is our median. Okay, so on the data set to the right and the data set to the left, you find that median, and so we get Q1 is 59, and we get Q3 is 73. Okay, the middle, right, those are also the medians of the data set on the left and data set on the right. So now you have Q1 and Q3. So that's 59 and 73. The median is 65, so a little bit closer over here. Now, how far can the whiskers grow? Okay. So what you do is to find the length of a whisker, what you do is you do 1.5 times Q3 minus Q1. So the difference, all right, the range, the interquartile range, okay, you can also describe that as interquartile range. So here we do 1.5, 73 minus 59. So 1.5 times, what is that, 14? So we get 21. Okay, So the length of the whisker is 21. So do Q3 plus 21 and Q1 minus 21, and that's how high and how low you can go. So this is how high you can go and how low you can go. So do 73 plus 21. We get 94. We get 59 minus 21, and we get 38. So technically, my whiskers can go out as far as 38 and as far as 94. However, in my data set, the smallest I really go is 56, and the largest I go is 98. So really, my whisker would go here. Then you would have your box, median, and then my whisker is going to go out as far as, let's see, as 94, but then it stops, right? You can't go past 94. 98 is considered the outlier. So 98 is your answer. Okay. So again, I know you could have just looked at it and could tell, but I want you to understand this formula. Okay. You can also use your calculator to double check yourself. So if we go to Stat, Edit, go to List 1, and let's clear it. And then type in your data set. So 56, I don't even have to do it in order. 73, 59, 98, 65, 59. Okay. 6, 7. Yep. All right. Then I'm going to go back to the main screen. So second quit. Then I'm going to do Stat, Calc. So Stat, and then to the right, one variable Stats. My list 1, I'm going to clear my frequency. I don't have a frequency list. And then here, I know it doesn't look like much, but if you scroll down, there's your Q1, median, and Q3. Okay, and it even gives your minimum and your maximum. I mean, obviously, you knew those already, but you see how everything worked out. My Q1 is 59, median is 65, Q3 is 73. So you can always use the calculator to double check yourself. And here are some more definitions. So first thing is range. Hopefully you understand range. That's just the spread of your data. So you take your largest value and subtract your smallest value every single time. Okay? Now, percentiles. I don't know what it is with percentiles, but everybody looks at these all weird. A percentile is a percentage, so it's from 0 to 100, and it shows the percent of the data that's less than or equal to that value. So, for instance, you see percentiles on SATs and standardized testing. So if you are at the 70th percentile, that means of all the other people that took it, you did better than 70% of them. That does not mean you did 70% of the answers correct. That is not associated with your score. It's how you compared to everybody else. Okay? So you got to be careful with percentiles. A lot of people start feeling negative when it comes to percentiles, and no, it's just comparing you to the rest of the data. Okay? And yeah, you got to make sure you've got quality data to be comparing to. Okay? Think about that too. So let's do an example with percentiles. So here are the scores on the midterm for a Spanish class. Okay? What is the 65th percentile? So what did you have to make to be in the 65th percentile? No, that does not mean you had to get 65% correct. It's 65%, okay, so 65% of the number of data. And there are, let's see, 1, 2, 3, 4, 5, 6, 7, 12, 18, 19, 20. There are 20 data sets. So 65% of 20. So it's your percentile times how many you have. Okay, it's percent of how many. Okay, so that is, well, 65 out of 100, or 0.65 times 20, so you get 13. So what that means, that's the 13th person in line. Now, when you say percentiles, all right, if I'm 65th percentile, that means I did better than 65% of the people. So you start at the bottom. Start at bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you had to get an 82 to score in the 65th percentile. All right, the 55th percentile, 0.55 times 20, that's going to give you 11. So it's the 11th person in line. So that means you had to score a 79. So think about what that means. You got 79% right. You almost got a B, and you only did better than 55% of the people. Okay, that means it's a good class. Okay, I think. All right, got a lot of people up there. Okay, I mean, to have only 2 Fs, not so bad, not so bad. The next one, 95th percentile, so 0.95 times 20. All right, and again, we get a nice number. If you were to get, say, like 19.231, you would round. Okay, you would, because again, you're picking the person, 19th person, 20th person. Usually, you'd round up. Okay, so here the 19th person would be at 98 because 100 would be 20. Ooh, why did I put 200? Silly me. All right, so to score in the 95th percentile, you had to score 98. Crazy, huh? All right, if you have any questions, come talk to me in class.